Hello students, in this video I will prove the result limit extending to a x to the power n minus a to the power n by x minus a equal to n into a to the power n minus 1, and I will solve some problems related to this result. Before proving this theorem, look at the formula. See, a minus b, I can write it as a minus b. A square minus b square, our formula is a minus b into a plus b. And a cube minus b cube is a well-known formula. We can write it as a minus b into a square plus ab plus b square. Just look at the second formula. Here see, power 2 is there, right? A square minus b square. Then we started with a minus b, and see here a power 1 is there, b power 0 is there. In the first term a power is 1, b power is 0. In the second term, a power is 0, b power is 1. So that a square minus b square is given means first we need to write a minus b. Then see, a power is less than the given power, that is a power 1, and b power, see here 1 is there. That means here you can observe, while moving to the next term, a power is decreased by 1 and b power is increased by 1. In the beginning a power 1 is there, then it will become 0. See, in the beginning b power is 0 here, but here b power is equal to 1. Look at the third formula, clearly you can see that difference. A cube minus b cube, first term I wrote a minus b. Then see here a square, because 3 is there means I need to start with 2, a square. Then see, a power is decreased by 1, a power 1, b power is increased by 1, b power 0 to b power 1. Then plus here we'll get b square and a power equal to 0. By this a to the power 4 minus b to the power 4 is there means I can write it as a minus b into, see 4 is there means I need to start with 3, a cube plus decrease, a power decrease by 1, that is a square, and b power is increased by 1, plus a power is decreased by 1, b power is increased by 1, and last term we can write it as b to the power 3. Or if a to the power 5 minus b to the power 5 is there means I need to start with a minus b into, here 5 is there means I need to start with a power 4, then a power 3 into b, next a to the power 2 into b to the power 2, next a into b to the power 3 plus b to the power 4 will get, right? See, a power 4, finally b power 4. Here see a power 3, here b power 3, a power 2 means b power 2, here see a power 1 means b power 1. Like this we can write any terms. One more observation, see here. First is all the sums are multiplied by a minus b, a minus b, a minus b, a minus b. And the second observation, see here power 2 means in the second sum we have 2 terms. Power 3 means in the second sum we have 3 terms. Power 4 means 1, 2, 3, 4. Again we have 4 terms. For 5 means in the second sum, not talking about all the terms, in the second sum we have 5 terms. Generally, if I take x to the power n minus a to the power n, instead of a and b, first term will be x, second term will be a. Then I can write it as, this is x minus a, right? See, a minus b into, see, power 4 means I need to start with the first term to the power 3. For 5 means I need to start with the first term to the power 4. So that x to the power n is there, so I need to start first term to the power n minus 1, one term less. Okay, plus next see, first term power decrease by 1, 4 will become 3. So x to the power n minus 1, that will become n minus 2 into second term power increase by 1. What is the second term here? A, will get a power 1. If you write the third term, see, plus x to the power again decrease by 1, n minus 2 minus 1, that will be n minus 3 and a power is increased by 1, a square plus dash dash dash, and the last term, see, last term to the power n minus 1, right? So that I can write it as it's equal to a to the power n minus 1. Here see, first a power 4 means last b power 4. So here x to the power n minus 1 means last term power, that is a to the power n minus 1. So we want this expansion here. So first consider x to the power n minus a to the power n. We know that x to the power n minus a to the power n can be written as, by using these observations, x minus a, first term x minus a is multiplied by, see, first term to the power 1 less, that is x to the power n minus 1 plus 1 power decrease by 1, see, x to the power decrease by 1, that is n minus 1 minus 1 is n minus 2 into a plus x to the power n minus 3 into a square plus dash dash dash, plus last term will be a to the power n minus 1. Powers will be same. First term x to the power n minus 1. Second, see, last term is second term to the power n minus 1. The next step, see, we want x minus a in the denominator. So dividing by x minus a, divide both the left hand side and right hand side by x minus a, so that I can write it as x to the power n minus a to the power n by x minus a equal to, see here, x minus a by x minus a, numerator 1 x minus is there, right, into x to the power n minus 1 plus x to the power n minus 2 into a plus x to the power n minus 3 into a square plus dash 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 a to the power n minus 1. It's not x, this is a to the power n minus 1. So here x minus a get cancels. Next what I want limit extending to a. So take limits on both sides. So taking limit extending to a, x to the power n minus a to the power n by x minus a is equal to, see, limit extending to a, x to the power n minus 1 plus x to the power n minus 2 into a plus x to the power n minus 3 into a square dash 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 plus a to the power n minus 1. Okay, now apply the limits to the left hand side. It's equal to, see, in place of x I need to take a, right? So first term is a to the power n minus 1 plus a to the power n minus 2 into, what is there, a is there, plus a to the power n minus 3 into a square plus dash 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 plus a to the power n minus 1. Now simplify this one. It's equal to, see, we have the basic formula, a to the power m into a to the power n is a to the power m plus n. So if you multiply a to the power n minus 2 into a means a power 1, right? What you will get? A to the power n minus 2 plus 1, it's equal to a power n minus 1. So first term will remain same, second term will become a power n minus 1 plus, look at the third term, that is a power n minus 3 into a square, it's equal to a power n minus 3 plus 2, right, m plus n. Again I'll get a power n minus 3 plus 2 minus 3 plus 2 is minus 1. Again it's equal to a to the power n minus 1 dash 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 plus a to the power n minus 1. Look at this one. Power 2 means how many terms in the second sum? 2 terms. Power 3 means we have 3 terms. Power 4 means we have 4 terms in the second sum. So here, see, after this, here how many terms are there? Here we can say that power is n means here n terms are there. Okay, we are adding a power n minus 1, a power n minus 1 n times. So it's equal to, see, suppose 3 is there. If I add 3 plus 3 2 times, I can write it as 2 times 3. It's equal to 6. Suppose 3 plus 3 plus 3. If I am adding 3 3 times, I can write it as, adding 3 3 times, you will get 9. Or if I add 3 4 times, see 3 plus 3 plus 3 plus 3, I can write it as I'm adding 4 3 times, so 4 into 3 is equal to 12. Similarly, 3 plus 3 plus dash 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 plus 3 n times, if I'm adding 3 n times, so that I can write it as 3 times n times 3, or I can write it as 3n, right? Similarly, a to the power n minus 1, a to the power n minus 1, a to the power n minus 1, adding n times, it's equal to n times a to the power n minus 1. Therefore, our formula is limit extending to a x to the power n minus a to the power n divided by x minus a is equal to n into a to the power n minus 1. Now see some problems based on that result. We need to apply this formula only when 0 by 0 form is there. Otherwise, we can do the direct substitution. Whenever the question is given in P by Q form, first check direct substitution is possible or not. If it is not possible, go for factorization method. Then also it is not possible to solve that one, means you can apply this formula. Okay. The first question is limit extending to 1 x to the power 15 minus 1 to the power 15 divided by x to the power 10 minus 1. Okay, so I can rewrite it as c limit extending to 1 x to the power 15, they may give it as 1, so 1 can be written as 1 to the power 15 divided by x to the power 10 minus 1 can be written as 1 to the power 10, because 1 to the power any number you will get at 1 only, right? Now see, our basic formula is limit extending to a x to the power n minus a to the power n by x minus a. We want x minus a in the denominator, then only we can write it as n into a power n minus 1. Look at this one, numerator we have, right, x to the power n minus a to the power n, but denominator not given, we want x minus 1. Here also see x to the power 10 minus 1 to the power 10 is there. To apply this formula, I want x minus 1 in the denominator, so that we can rewrite it as it's equal to limit extending to 1 x to the power 15 minus 1 to the power 15 divided by x minus 1. First, I'll divide the numerator by x minus 1, whole the sum divided by, see here, x to the power 10 minus 1 to the power 10 is there, then divide it by x minus 1. So without changing the problem, see, we can divide both the numerator and denominator. See, if you rewrite this one, x minus 1 get cancelled, so that we will obtain the given problem itself. Now see, numerator is of the form, this much is of the form x to the power n minus a to the power n by x minus a. This is nothing but n into 15 into a to the power a is 1 to the power 15 minus 1 divided by, see, denominator also in the same form, right, x to the power n minus a to the power n by x minus a. This is nothing but n into a value is 1 to the power 10 minus 1. It's equal to, see, 1 to the power any number, it's equal to 1. Here 1 to the power 10 minus 1, 9. It's equal to 1. So 15 into 1 is 15 divided by 10 into 1 is 10. So I can write it as, we can divide it by 5, right? 5 3s are 15, 5 2s are 10. So answer will be 3 by 2. Look at the next question. Limit extending to 3 x to the power 4 minus 81 divided by 2x square minus 5x minus 3 is there. Okay. See, first check this one. In the previous problem also, see here, x to the power 15 minus 1 by x to the power 10 minus 1 is there, means here if you take 1 means 1 minus 1 by 1 minus 1, it is 0 by 0 form. That's why I am applying this formula. Here also, see, you can check, if you substitute 3 to the power 4 is 81 minus 81 divided by, see, 2 into 3 square 18 minus 5 3 is 15 minus 3. See, 0 by minus 18 plus 18 0, 0 by 0 form, right? So we need to simplify this one. For that reason, see, I can rewrite it as limit extending to 3 I will keep x to the power 4 as same x to the power 4. 81, see here 3 is there, right? I can write it as 3 to the power 4 because 3 to the power 4 is equal to 81. Our aim is to convert the given question into this form, x to the power n minus a to the power n by x minus c. So divided by, we can't directly simplify this one, so go for factorization method. See, 2x square minus 5x minus 3 is there. Multiplying AC value, what is AC? 2 into minus 3 minus 6 I want, but adding we want minus 5. Adding minus 5 and multiplying minus 6, so that okay, it's not possible to take 3 and 2 because minus 3 minus 2 will get plus 6, not minus 6, right? So 3 and 2 is not possible, so try 6 and 1. We want minus 5, so that I can take minus 6 and 1. Minus 6 into 1 is equal to minus 6. So factorize, we can write it as 2x square minus 6x plus x, and here we can see minus 3, right? Minus 3. So in the next step, see, take the common terms outside, limit extending to 3, x to the power 4 minus 3 to the power 4 divided by, here I can take 2x outside, so that x minus 3 is remaining, plus 1 into x minus 3. Plus 1 is because we want the common term inside the brackets, right? So in the next step, see, limit extending to 3, x to the power 4 minus 3 to the power 4 by, here x minus 3, here x minus 3 is there, so take x minus 3 outside, remaining term is 2x plus 1. In the next step, we can regroup it as, it's equal to, see, limit extending to 3. First term is, I can keep 1 by 2x plus 1 outside, into second term is x to the power 4 minus 3 to the power 4 by x minus 3. Why? Because it is in the form x to the power n minus a to the power n by x minus a. Now apply the limits. It's equal to, say, 1 by 2 into x value is 3 plus 1. It's the first term, into second term will become x to the power n minus a to the power n by x minus is n into a value, a power is 3 to the power n minus 1, that is 4 minus 1. So that it's equal to 1 by 2 into 3, 6 plus 1 into 4 into 3 to the power c, 4 minus 1 is 3 will get. Okay. So that here it's equal to, see, 1 by 6 plus 1 is 7 into 4 into 3 cube, 3 3 is 9, 9 3 is, it's equal to 27. Okay. So if you multiply this one, you will get it as 108 divided by 7. No need to write it in decimals, you can keep the fraction itself. The next question, limit z tending to 1, z to the power 1 by 3 minus 1 divided by z to the power 1 by 6 minus 1. Again, by looking at the question only, you can observe, right? It is in the form x to the power n minus a to the power n, denominator also x to the power n minus a to the power n. So that we can rewrite it as limit z tending to 1, z power 1 by 3 minus, I can write 1 power 1 by 3, because 1 to the power 1 by 3, again it's 1, and z power 1 by 6 minus 1 power 1 by 3 is there. And look at this formula, what we missed here. Again we missed x minus a, right? Denominator z minus 1 we want. So same procedure, limit z tending to 1, divide both the numerator and denominator by z minus 1. So that z power 1 by 3 minus 1 by 1 by 3 divided by z minus 1. The sum is divided by z power 1 by 6 minus 1 power 1 by 6. Okay, here we need to write 1 power 1 by 6, n value is 1 by 6, right? 1 power 1 by 6, denominator again same, z minus 1. Now both the numerator and denominator in this form, so apply the formula, that is n into a power 1 by 3 minus 1 divided by, here also n 1 by 6 into a is 1 power 1 by 6 minus 1. Now see, it's equal to 1 power any number, it's equal to 1, Here also 1 by 6 minus 1, its power, it's equal again 1. So the remaining sum is 1 by 3 divided by 1 by 6. You know the calculation, right? 6 will move to the numerator, 1 will move to the denominator, so that I can write 6 by 3. So answer is equal to 2. 2 will be the value of the given function. Next question, see, limit extending to minus 2, 1 by x plus 1 by 2 divided by x plus 2 is there. So basic formula we have 1 by a to the power m can be written as a to the power minus m. For example, say 1 by x square is there, means I can write it as x to the power minus 2. So using that one, here see we can rewrite the given question as limit extending to minus 2. 1 by x I can write it as x to the power minus 1. 1 by x means power 1 is there, right? If you take it to numerator, power plus will become minus, minus will become plus. So see, middle plus is there, but look at our formula, no plus, right? Middle minus, so I'll keep minus outside, and see here I'll put minus. So minus into minus, again we will get the plus that is given in question. And 1 by 2, 1 by 2 means 1 by 2 power 1. If you take it to the numerator, 2 power 1 will become minus 1. So that 2 power minus 1 divided by x plus 2 is there. We don't want plus in the middle, so we can rewrite it as x minus of minus 2. Now see, this is in the form x to the power n minus a power n by x minus a, and our a equal to minus 2 itself, right? So we can apply the formula, that is equal to n is minus 1 into what is a is minus 2 to the power n minus 1, n is minus 1 minus 1 by the formula. So minus 1 into minus 2, minus 1 is minus 2. So that in the next step, see, minus 1 into, see, a to the power minus m is there, right? We can rewrite it as 1 by, shift it to denominator, power will become plus m. So that I can rewrite it as 1 by minus 2, no change in a, but minus 2 will become plus 2. So minus 1 into 1 by minus 2 the power 2, even number, that is equal to 2 square, so we will get plus 4. Power is even means you will get positive, power is odd means you will get negative, right? So minus 1 into 1 by 4, minus 1 into 1 is minus 1 divided by 4 will be the answer. Next is problem is based on change of limit, and it will begin in the 0 by 0 form itself. Okay, here see, change of limit means actually our formula limit extending to a x to the power n minus a to the power n by x minus a. Look at this one. Here can observe limit extending to 0 is there. Here limit value equal to a value is equal to 0. But here see, a value equal to 1 is there, right? So either we need to change the limit and we can solve, or directly by rewriting this question also we can solve this problem. So I'll do that in two methods. First one, see, I will take the given question as see x plus 1 to the power 5 minus 1 to the power 5. Now it is in the form x to the power n minus a to the power n divided by I want x minus a. In place of x, you can observe x plus 1, right? So I'll write x, then minus a, will write it as minus 1, because see plus 1 minus 1 get cancels, so that we can get x itself. But see, very important observation, while changing this one we need to change the limit also. So here x is replaced by, say, limit, in place of x what you can see, x plus 1 tending to a, actually here 0 is given but I changed it to 1, right? A power n x minus a, so I can write it as x plus 1 tending to 1. Limit x plus 1 tending to 1, x plus 1 to the power 5 minus 1 to the power 5 by x plus 1 minus 1. So that now it is in the form, see, limit x tending to a, x to the power n minus a to the power n by x minus a, it's equal to n into a power 1 power n minus 1, that is 5 minus 1, it's equal to 5 into 1, it's equal to 5. It's a one method. Or if you do changing the function, see, we can write it as limit extending to 0 x plus 1 to the power 5 minus 1 by x is there, right? I'm completely changing this function to another function. So take x plus 1 equal to one function y. This implies we can see x value will become x minus 1, taking 1 to the right hand side, so that x is equal to y minus 1. Next, see, I changed x into y, right, in terms of y. But see, limit is given in terms of x. So change the limit also. See, as x tending to 0, x value becomes 0. What will be y? Take here equal to 0. See, 0 plus 1 will get y tends to 1, right? So rewrite this one. Limit x tending to 0 will turn as y tending to 1. What is x plus 1? Y to the power 5 minus 1 divided by what is x? Here see, x value is equal to y minus 1 is there. Now we can observe, right? It is in the form x to the power n minus a to the power n. 1 can be written as 1 to the power 5 by y minus 1. X minus a form is there. Its value is equal to n. 5 into a 1 to the power 5 minus 1. It's equal to 5 into 1 power 4 is 1. Again we will get 5. Second question, see, limit extending to 0 root of 1 plus x minus 1 by x is there. I will solve this by using first method. So limit see, extending to 0, root of 1 plus x is nothing but x plus 1 to the power 1 by 2, right? Root x means x power 1 by 2. So that I can write it as x plus to the power 1 by 2. So x plus 1 to the power 1 by 2 minus 1 can be written as 1 to the power 1 by 2 by x is there. But I want x as x plus 1 and a as 1, but here a value equal to 0 is given. So change the limit. So see, first I'll write the function x plus 1 to the power 1 by 2 minus 1 to the power 1 by 2 by what is x? You can observe, right? X is x plus 1. What is a is there? Here I can write it as minus 1. So plus 1 minus 1 get cancelled. Again we'll get x. Now see, limit. You can observe we changed x as x plus 1 tending to changed a. Actually here 0 is there. I changed it to 1. Now see, it is in the form limit x tending to a x to the power n minus a to the power n by x minus a. It's equal to n into what is n 1 by 2 into a value. What is a? 1 to the power 1 by 2 minus 1. So that 1 by 2 into whole this value will become 1, right? Answer is equal to 1 by 2.